We will do the implementation of protecting our STP topology in this diagram, right? Now in this diagram, I can assume that VDC1 is the root, right? Why? Because it has the lowest MAC address. That's what I know. So he becomes the root. If he becomes the root, then I should have this port being the root port, this port being the root port, and this port should be the root port. And because of that, my designated port should be this. All the ports of your root are designated ports. This port should also have a designated port. Why? He has second lowest MAC address, right? This port also has the second lowest MAC address, so this should be the designated ports. The rest of them should be blocked like this. And this switch, I may simulate that as a PC or a switch, both, okay? So if I simulate that as a PC, I'll give it an IP address. If I simulate that as a switch, I'll leave it like that, right? So now this port, which is connected to the, I'm not taking this as a switch. This is a PC, okay? So generally, what port should that be? A designated port, right? Let us have some VLANs configured on the switch. We'll have VLAN 1 to 50 configured on the switch, where for all the 1 to 50 VLAN, let him be the root. I'm not following a best practice out here, but just for the sake of understanding our configuration, right? So I've already made the topology. We just need to go and make some trunk interface, because by default they are only access ports. So I'll just go to my, so good thing that you can do from your secure CRT is we can make VLANs. So VLAN 2 to 50 is what I'll make on all the switches, right? So if I have done that, so all the switches will have VLAN 2 to 50. That's what I need. But on my VDC1, the interface, all of them should be trunk ports. So I'll go to interface Ethernet 5/9, Ethernet 5/23, Ethernet 5/32. Switch port mode is trunk. No, shut. For VDC2, interface Ethernet 5/34, Ethernet 5/12, and Ethernet 5/27. Switch port mode is trunk. No, shut. VDC3, interface Ethernet 5/10, Ethernet 5/11. And what would you do with 42? Generally, this would be access port. So I'll make this as access port. Later, I'll do that. Okay. So switch port mode as trunk. No, shut. VDC4, interface Ethernet 5/24, Ethernet 5/25. Switch port mode is trunk. Show spanning tree. Should show me all the ports that I want. 5/9, 23, 32 should be all what ports? Designated as we guessed, right? And that should be in forwarding state. Any port that has 19 there, if you see that in your lab, just go to that port and change the path cost, because those are faulty cables. Okay, I don't see 19 here, so I'm safe. So spanning tree for VLAN 10, nothing is 19 here, so that's fine. Now let me check show spanning tree for VLAN 10 here as well. So 5/34 should have been the root port as we guessed, right? 12 and 27 should be the designated port. So I see only 12, I don't see 27. So let us check 5/27 brief. It is down, it shows me link not connected. So there must be some faulty cable. Well, the cable may be missing totally. So 25 to 27, I don't see this. I'll use one of them, okay? 1/1 to 2. Let us check that out. I'll just make this 5/1 to 5/2. So I go to VDC1, allocate the interface. So we'll go to VDC4 and allocate interface Ethernet 5/2. And for VDC2, I'll allocate interface 5/1. So VDC2 will go to that interface and give the command switch port mode is again trunk. VDC4 also I'll do that. Show spanning tree. Should show me the 5/2 coming up. Show interface Ethernet 5/2 brief. And this also shows down. Show CDP neighbors. Show interface Ethernet 5/1 brief. Okay, this shows up. This should also be up. Right? Now it's fine. So if I do show spanning tree for VLAN 10, I see 19 here, right? This is a faulty port, that's why. So I will go and change the path cost to the normal. So which is how much? 4. Spanning tree for VLAN 1 to 50, cost is 4. Then I have to do that on other side as well, which is VDC2, because here also show spanning tree for VLAN 10 or any VLAN you see that has 19, that is faulty. So spanning tree for VLAN 1 to 50, cost is 4. That should fix my issue. Show spanning tree for VLAN 10. So one of the port is blocked, which is 5/2. As we have guessed, 5/2 should be blocked, 5/24 should be the root port forwarding. And with VDC3, let us check that out. Show spanning tree for VLAN 10. 5/10 should be the root port. So 5/10 is the root port, 5/11 should be blocked. So it's fine now, right? Now, the first thing that we'll see here is your BPDU filter. So BPDU filter means it can be done under the interface. It can be done in a global mode, right? Let us do first under the interface. Now say this was a PC, switch 1 was a PC, right? PC would not send any BPDUs first of all, right? Or the thing is, if I go to VDC3 on that interface, if I go and normally that interface Ethernet 5/42 connected to this switch would be switch port. Switch port mode would be what? Access. And say switch port access 1 of the VLAN 10. Not only this, I would give spanning tree, port type, edge, right? No shut. So all of these things are configured on this access port. Port type edge, port fast, and all those things, right? But one thing that we know is if I go to switch 1 and turn its interface up, which is interface G1/0/22, I'll give it a IP address. So I'll give no switch port. I'll give it a, say, any IP. I'll do no shut. Any IP doesn't matter, okay? I'll do no shut. So this interface of the switch is a layer 3 interface. Now it's a layer 3, no BPDUs. But the thing is, the problem is, even if I configure port fast, if you do show spanning tree for interface Ethernet 5/42 detail, right? So 5/42 is what port? Designated forwarding port. And when it is designated, it will send BPDUs, right? And the counter goes on increasing because I'll send it after every 2 seconds. I am wasting my bandwidth uselessly by sending BPDU to a device who does not understand BPDU. That's why I have passive interface for EIGRP, RIP, right, to stop the hellos going. Similarly here also, with spanning tree, I have what? BPDU filter that can be done under the interface. So I can go to the interface Ethernet 5/42 and give what command? Spanning tree BPDU. Actually, that filter and guard same commands, right? So I'll write filter and enable or disable. So enable, enter. Now this will enable BPDU filtering, right? How will I verify that out? Show spanning tree, again interface Ethernet 5/42 detail. It should not be sending BPDUs, right? And the counter should remain the same, 35. It's still 35. If you want to clear the counters, you can give the command clear spanning tree counters. That will clear your counters of spanning tree. Okay, so it's 0. Now, no BPDUs are being sent. That means this is working in which direction? Out direction. Let us check if it works in direction as well. How would I check that? Make the switch a switch, right? How would I make the switch a switch? Go and just give what command? Switch port. Under which interface? G1/0/switch port. That's it. Now it should send what? BPDUs. Can I verify that out too? Yes. Show spanning tree for interface G1/0/22 detail, right? That verifies that I am sending BPDUs. And I am doing that after every 2 seconds. As you see, the counter increases here. But on VDC3, did I receive? It filtered. Means it worked on which direction also? In direction also. In and out, both working fine, right? But did something happen to the port? Did the port went down? The port is still up, right? The port is still up, though it's not put into error disabled state or something like that. Just BPDU has been filtered, nothing more than that, right? And BPDU has been filtered in which direction? Both the directions. Let me remove that out. So you can verify that the BPDU filter is enabled on that itself, you'll see, right? Now I'll just remove it out. So spanning tree BPDU filter enable, no. Right? Now if I check again, it's not there. And why? It's receiving now, so that's removed, right? Now let me just make the switch a router. How do I do that? No, switch port, that's it. Makes a router. Doesn't send any BPDUs, and the counter of received would be like 0. Now what I do, I can enable the command on a global mode. Spanning tree, port type, edge. If you give a question mark, you see BPDU filter, BPDU guard, both. So if it's related with what? Port fast. What is this command telling? Wherever port fast has been enabled, also enable BPDU filter there. Right? So the first criteria is port fast should be enabled on that interface. Whereas if I go to the interface and do it, it doesn't require the port fast to be enabled. Right? But in a global command, it does require the port fast to be enabled first, which we already have because we have configured that particular port type as well. Edge. Right? So I'm giving the command and default. So enable BPDU by default on all edge ports only, on all port fast enabled ports only. That's what it's telling, right? So I'll give the command default. What should this do? Show spanning tree Ethernet 5/42 detail. That counter should stop, and it stopped, right? Clear spanning tree counters also you can do and check it out. No BPDUs are being sent. Currently it's sent, but see.
Global mode and different.
Right? Now why is sending? If you see BPDU filter is enabled by default, right? This is a port type edge also, but let us check. Show spanning tree. How do I check port fast is enabled or not? Show spanning tree, port interface, Ethernet 5/42 edge. Port fast is also enabled on that port, right? So let me do again. Interface Ethernet 5/42. It's a edge port. Detail. Okay, now it has stopped. This is a bug actually. Okay, it has stopped now. But if I go to the switch, right, and make it switch port, when I make the port as a switch port, what will happen to your port first? Gets disabled as soon as it receives a BPDU, right? What would happen to the BPDU filter then? Gets disabled. Means this does not work in which direction then? In. It did work in out direction, right? Does not work in which direction? In, because it's related with what? Port fast. What happened here? BPDU got in, port fast got disabled. Port fast got disabled, BPDU filter got disabled. So which is a better command to give then? Under the interface or a global mode? Interface. Why? It does it in both directions, not related with port fast. Are you getting my point? If it's related with port fast, then as soon as a BPDU comes in, BPDU filter gets disabled. So the BPDU filter gets disabled. Port fast got disabled, BPDU filter got disabled. But when I did it under the interface, was it related with port fast? If port fast was not there, also BPDU filter was still enabled, right? So interface level command is a better command for BPDU filter rather than a global command, because for a global command, as you saw, it worked in which direction only? Which direction? Out. Didn't work for in direction. But interface level command, it will works for both. But even after doing that, the interfaces are still up state. BPDU is only filtered if it is, right? So the difference between BPDU filter and BPDU guard is BPDU guard completely shut down the port, right? If I now say I remove that, so the command that I gave, I'll remove that. Spanning tree, port type, edge, BPDU, filter, default. Remove it, right? And I will go to the switch, make it a normal router. Now it doesn't send any BPDUs. I go to the VDC3. Now I enable BPDU guard. How do I do it? Go to the interface, spanning tree, BPDU, filter guard, same command, right? Guard, enable. This should enable BPDU guard. Now show spanning tree for interface Ethernet 5/42 detail. Right? Does BPDU guard stop sending BPDUs? No, it's not filtering BPDUs. Remember that. BPDU guard is not filtering your BPDUs. BPDU guard, after enabling it, what is also happening? BPDUs are being sent. It's not like BPDU filter. Okay, BPDU guard implementation does not mean that you are stopping the BPDUs from sending outside. So still you'll implement BPDU filter in this case, right? But what does BPDU guard do? If in case the switch sends BPDUs, I give a switch port command, right? What will the VDC3 start doing? There is no information of spanning tree available. Why? Because show spanning tree for that particular show spanning tree does not show you that port also, right? 5/42. Why? Show interface status BPDU guard error disable state it was put into, right? And if you do show interface status error disabled, it gives you a reason. The reason is BPDU guard put that into error disabled state, right? Now if you do show error disabled recovery, you see that the recovery for BPDU guard is by default disabled. For anything, it's actually by default disabled. There are many causes, as you see, a lot of them, right? So everything is by default disabled. This does not come up by default. So even if you make this switch a router, and it does not generate any BPDUs now, right? The problem is solved. But will the interface come up? It's still in which state? And forever will remain in error disabled state until somebody comes and do what? Shut, no shut on the interface. One of the way to do it. But since the administrator will not be available all the times, right? I will rather give what command. If I do right now this and see the status, none of the ports is in error disabled state, working fine, right? Or another way is error disable recovery cause, right? So there are a lot of causes. You can mention all, or you can mention a particular cause. BPDU guard, right? You do show error disable recovery. It should be enabled for BPDU guard. And then in case now, say for example, I give switch port, it again puts that into error disabled state, but it will attempt to recover it after 30 seconds. Right now the default is 300. So I can decrease that time also by giving error disable recovery interval. The minimum you see as 30 seconds, right? So say I want 30 seconds, let it recover. But it will try to recover only. The BPDU still comes, again puts the port into error disable state. Okay, if the problem is fixed, because if everything was done by spanning tree, I would have no job, right? First of all. So there should be some job for the administrator as well. Go shut, no shut. Mention some timers there, right? So it will attempt to recover, but will not be able to recover until unless I give what? No switch port, right? So we have to wait for some time for it to come up. Let us check. It is in what state? Error disabled state. So after approximately 30 seconds, this should work and recover it back. See, 30 seconds seems a long time, right? When we are doing practicals, right? 30 seconds while talking just goes like this. So that's why production network means every second counts, right? See, your manager is sitting on top of you and you see this, what will happen?
He just goes for a beer.
Seems a long time, right? So the timer by default was previously 300. That is when you don't mention the recovery interval. It takes a default of 300 seconds.
Change it for everything, right?
30 change it for everything.
We change it only for BPDU.
That command, I don't think that's good. So if you check error disable recovery interval is 34, it doesn't. Yeah, I gave no switch port. Because if you check show spanning tree for interface G1/0/22 detail, no spanning tree information should be there, right? Yeah, clock is. Anyways, what is the another way of doing it? The same thing on the global mode, right? How do I do it on a global level? We first need to say remove from the spanning tree BPDU guard, enable, remove it, right? And do it on a global mode. Spanning tree, port type, edge, Filter guard, default. This will also do it, but here BPDU guard works before port fast. This works in both directions. In BPDU filter, what first worked? Port fast worked first. But in BPDU guard works first. Then port fast. Means if a BPDU gets received, it gets disabled. It doesn't check port fast. BPDU gets received, port fast gets disabled, and BPDU guard gets disabled. That doesn't happen in BPDU guard. In BPDU filter only it happens. It does not happen with BPDU guard. So a BPDU guard giving it in a global command or an interface level command works in both the directions. It works in both in and out direction. Okay, let us verify that out. So if you check right now, show interface status error disabled, that's still it's in a disabled state. So I'll just go to shut, no shut, check again, it's fine. So if I do currently show spanning tree interface Ethernet 5/42 detail, BPDU guard has been enabled, right? And because port type is edge, if it was not, then it would not have been, right? So if I check show spanning tree for any VLAN 10, that port is what port? Edge point to point port where BPDU guard has been enabled, right? But this has not been done under the interface. I did it in a global command. There is no command under the interface. It's one command is only there, port type edge, right? BPDU guard is on a global mode. Let us try to send what? BPDUs switch port, right? Would send BPDUs. What happened now? See, BPDU guard worked, right? In which direction also? In. It didn't work for BPDU filter. So BPDU guard and BPDU filter has a difference in the way we configure it in the global mode. If I configure BPDU filter in the global mode, it works only in which direction? Out. If I do it with BPDU guard in a global mode, it works for both in and out direction. Okay? Everything clear till now, right? Now, in order to simulate another topology, I need to just remove this link because I cannot show you that without removing this link. So I'll just remove this switch completely from the diagram. Okay, the switch is no more there. If this switch is no more there, this is the same topology I'll still get, right? So to remove that switch VDC4, I'll just go to my interface Ethernet 5/2 and 5/ shut it down. Okay, just remove it from the topology. In my topology, I have VDC 1, 2, and 3 only. Okay, and let us verify that if VDC 3 is still so spanning tree for VLAN 10. VDC 3, what is the block port? 5/11 is the block. This is my root port, right? Everything is fine until somebody comes here on this interface and does what? Filters the BPDU. Because this port was getting what BPDU? Superior. As well as the block port is also getting superior BPDU right now. That's why, because the cost here is just 4 and the cost here would be how much? 8. That's why it's preferring this path as my root port, right? But if somebody comes on VDC 1 and does a BPDU filtering, currently let us verify, show spanning tree for interface Ethernet 5/9 detail. So I should see that the 5/9 is sending BPDUs for all VLANs, right? It has sent so many BPDUs till now. Now I do what? 5/9. Go and there give what command? Spanning tree. But you cannot do it for, in this case, for what? Per VLAN basis, right? You can do it per
interface.
Interface only. It does not tell you to do BPDU filter per a VLAN basis, right? So we can do BPDU filter. There, what happens then? Enable. Stop sending BPDUs. If it stops sending BPDUs, what will VDC3 do? Became designated port, and it's a designated port, right? See, rapid is rapid only when the other side is also rapid. Now I am stopping sending the BPDUs, means I have stopped the proposals. I told that in such cases it not be rapid, it still has to go through which phases, and that's what is happening, as you see, right? It's going through listening, learning, forwarding, designated forwarding, another port also forwarding. Every port is forwarding. If you check on VDC1 also, show spanning tree for which VLAN? Forwarding all ports. VDC2 also. Forwarding. VDC3 also. What happens then? Loops, right? Loops are created because of this, and it may be because of unidirectional link as well. In case we have fiber optic cables, it may be because of a BPDU filter. It may be because of a switch not able to generate BPDUs because the CPU process of the switch was very high. Many reasons are there for this to happen, right? So it's good that we implement what feature here? Loop guard. How do I do loop guard? Let us remove the filter first. I'll remove the filter, right? Should send BPDUs again, should be fine again. That port is blocked, everything is fine when BPDU is received, but when a BPDU goes missing, that's when a problem occurs. So what I can do is either I can go to that interface Ethernet 5/10 where I detected the problem, but for this I need to detect the problem first of all, right? So it's better that you do it in a global mode, because here also I give the command spanning tree guard root or loop, as loop in this case, right? I do this, or better spanning tree loop guard default. So this does not tell you on access or trunk ports. This is on all ports. So this is a better command actually. Do it on all ports. Doesn't make a difference, right? Now I do what? On VDC1, I go back, do BPDU filter. Right. Now what happens in VDC3? Show spanning tree for VLAN 10. Which state did it go in? Broken state. And what is the reason? Loop inconsistent. Right. Show spanning tree inconsistent ports. Shows that it went to inconsistent state for all the VLANs. Why? Because I did BPDU filtering for all VLANs. If I could do it for one particular VLAN, it would have done it only for that VLAN. But I could not do that, right? So it put the port into loop inconsistent state. The thing about this is it does not need a timer, right? It does recover automatically when the problem is fixed. So when the problem is fixed, it should recover automatically. You don't have any inconsistencies, and that should work fine again. Right? Did you understand what is a loop guard? Why it's there? A loop is caused. To prevent that, you have loop guards. Loop might be caused because spanning tree works totally on BPDUs. So if a switch is not able to generate BPDUs, loops might be caused. Right? So it's very good to implement this loop guard. Right? Root guard. Let us see what root guard does. So we saw what loop guard does, but actually that was before I had to do loop guard, right? Root guard, what does it do? Root guard protects against superior BPDUs, right? How do I enable it? Under the interface only it's able to enable it. It's not a global level command because we cannot do it in globally, right? We have to do it under the specific interface. If I do it globally means you are destroying your network then. I will receive superior BPDU, right? On the root ports. I have to. So where would I implement my root guard here? 5/9 or 5/23 it was VDC4, right? Or 5/12 or this ports, not this port. Don't. If you do it in this port, what happens then? He will block the port because he is the root. He will send superior BPDUs, right? So do not do it sideways. Do it downward facing ports. Okay. So let us try that out. We'll go to which VDC? VDC1. Is he the root right now?
Yeah.
He is the root for which VLANs? All the VLANs, right? 1 to 50. This bridge is the root. Why? He has the lowest MAC address. The thing is, I was lazy not to go and give or hard code the root, right? By changing the priority value to how much? 0. Right? I was lazy. I didn't do it. Everything was default. Default only made the root. Okay, fine. I didn't put extra efforts to make it root manually. Right? And if you don't do that and somebody comes and connects a switch, right? And this is switch connected. If in case he had a lower MAC address, and obviously lower end switches will have lower MAC address. Nexus switches will have higher MAC address, right? Lower end switches, so since they are lower, older switch will have lesser MAC address. So if in case I go to switch 1 and let us check the MAC of switch 1, show version should show you the base MAC address. This is the MAC of whom? Switch 1. Okay, let us check the MAC of VDC 1. So VDC will show you that, right?
Yeah.
Let us compare. But this shows you which is a lower. VDC1 is a lower. So it will not, nothing will happen in case I connect the switch. But sometimes it may happen that you do not do write erase and just connect the switch. The switch may already be having a command spanning tree for VLAN 10. Priority is 0. It may already be having this command and it's running config or maybe startup config. Nobody removed or nobody erased it, just connected it to our network, right? Now it will generate BPDU right now nowhere because it doesn't have any ports to generate, right? Until and unless I go to that interface, but it will already stop us, right? Because we have implemented what? What have you implemented here? BPDU guard. So it will already stop that from happening. So I'll just remove it. You say you didn't do anything there. So interface show run interface Ethernet 5/42. Port fast is there. And I had given BPDU guard command under the global mode, right? So I'll give the command no spanning tree port type edge BPDU guard default. That should remove. So spanning tree, interface Ethernet 5/42 detail. 42, that information is not available. Sorry. So I'll reset the interface. Okay, it's fine now, right? Receive some BPDUs. Right? Receive BPDUs, but what happened? What happened to VDC1? Show spanning tree for VLAN 10. Is he the root anymore? Entire topology changes, right? Switch 1 is now the root, which you have just connected to your network. All the topology changes, all the root ports, designated port changes, and changes means the traffic that were flowing will be affected. Yes. So what should you do there then? So if I do shutdown right now, let me just shut it down so that it does not generate any BPDUs, right? Now in VDC1, if it does not get BPDU, it should again be the root. That's fine. But on top of that, I will also implement root guard. On which interface? Ethernet 5/9 spanning tree guard root. Right? And I should do that on 5/12 or VDC2 as well. What command? Spanning tree, God, root. Currently, nothing happens. Why? So, spanning tree inconsistent ports, if you see, nothing happens. Why? No superior BPDUs are received. If inferior BPDUs are received, that's fine. But in case I do no shot to this port, we start generating what? Superior BPDUs. As soon as a superior BPDU comes on a port, what happens now? But only for that VLAN, as you see, right?
Yeah.
Are other VLANs affected? No. So that's why it is in which state? Actually, broken state. It's not completely blocked. It's blocked only for that VLAN. Because if you check for spanning tree for VLAN 10, that's where you'll see if that port is in. But for 20, it's fine. No problem with 20. And this will automatically fix when what happens? When I go and give no spanning tree for VLAN 10, priority is 0. He again generates what type of BPDU now? Inferior, right? And that should work fine for 10, right? It will recover, but only after some time. Okay, so if you do show spanning tree inconsistent ports, it takes some time to recover, approximately 30 seconds. But this will recover automatically. You don't have to put any timers to do that. Did you get this, guys?
Yeah.
Right? Root guard, loop guard, BPDU filter, BPDU guard, root guard. This is for any BPDUs coming in, right? This is for BPDUs to stop. Where on the ports where it was unexpected, right? But for the ports where we expected, I implemented one loop guard that will put the port into inconsistent state. One more thing I can do is UDLD, but the thing is I don't have fiber optic cables, right, connecting the switches, so we cannot simulate a unidirectional link. Can we implement UDLD in an Ethernet port? Yes, it is possible. Okay. Now the way to implement UDLD, in case you do it, say we do it between VDC 1 and 2, we have to do it with the help of first command is feature UDLD. It has nothing to do with spanning tree, it's its own protocol, right? So feature UDLD, and I will do that on say VDC 2 as well, right? Feature UDLD. Now to enable UDLD, you give the key command UDLD itself. UDLD question mark. Aggressive means which mode? Aggressive mode, but you clearly see all fiber optic ports only. It does not apply for Ethernet ports if you do it in a global mode, right? And you can change the time, as I told, message time, which is by default of 15 seconds. Minimum that can be changed as 7 seconds. Okay, the whole time will automatically be 3 times of it. So if 7, 321 seconds. And you can give the command UDLD reset, that is for putting the port from error disabled state. If the port goes into error disabled state because of UDLD, you give the command UDLD reset to do that, to recover the port. Okay, but you don't see a command that actually enables for Ethernet interface here. But if we go to the interface Ethernet, which is my say 5/32 interface connecting to VDC2, here you do have the command, and that can enable for even your Ethernet interface. But in Ethernet, I don't face such problems of unidirectionally. Okay, so I don't face problems. So I have what command? Enable. Enable means which mode? Normal mode. Nothing is done, just a syslog message is generated. Aggressive means what mode? Aggressive mode. It will put the port into error disabled state if I do this, right? But you can simulate this in Ethernet if you want to. How can you do that? BPDU filter does not stop UDLD message. See, what I need, this is a task for you guys, okay? I'll not do it, I'll just tell you how to do it. So this is a task you should do and research on it. Because right now I have two switches, VDC1 and 2. Right? Can you apply BPDU filter to stop UDLD message? See, if I apply UDLD message on Ethernet interface, what happens? UDLD will go bidirectional right now, right? How can I simulate a unidirectional link? I have to stop this message, UDLD message.
Okay, do no to UDLD on one side.
So you need to stop UDLD message. You cannot give no UDLD. If you give no UDLD, it will stop detecting the message. It still should detect, right? After enabling UDLD, you stop the UDLD message. By what can you stop the UDLD message? VLAN access list. Using MAC access list combination. Have you done VLAN access list? You should do it, because if you have done CCNP, you have to do VLAN access list. CCNP is incomplete without a VLAN access list. So VLAN access list along with MAC access list is what you need to use. You need to figure out what is the multicast MAC address used by UDLD. And the hint is STP uses the same, CTP uses the same, VTP uses the same MAC address. So if you can find out what is STP use MAC address, and then you can use MAC access list to filter the UDLD message. So you check out in Google, right? What is the MAC address of what? UDLD.
UDLD messages.
MAC address of UDLD. Which MAC? Destination. So this is the one. This is the MAC of UDLD. So what you need to do here? Match this MAC with the MAC access list. Go to the VLAN access list. In the VLAN access list, you need to take action as drop. For the rest, you need to take the action as forward. And then unidirectional link detection would be happening because we are stopping UDLD message, right? UDLD message should be bidirectional. After that, you can check this and simulate it, but this is a task for you.
This is simulation.
Yes. Because you want to check, right? UDLD implemented, what will happen? You don't know. So what is the thing? So you should know what will happen if UDLD is implemented. So you have to check it this way. Please do it, okay? This is your task. You don't need a Nexus switch for this. You can do it in normal switches also.